Okay, let's talk about gas density and molar mass. So using the ideal gas law, we can calculate the moles in 1 liter at a given temperature and pressure. And then from the molar mass, we're able to calculate density, which is a relationship between mass and volume. So the two forms of this equation that we might find helpful is D, lowercase d is density, equals P, pressure in atmospheres, times molar mass of that gas over RT if you're solving for density. Or if you're solving for molar mass, you could just rearrange it. Molar mass equals density times RT over pressure. So because the molar mass is going to be in a unit of grams per mole, and because my volume in my ideal gas constant, R equals 0.0821 liter atmospheres per mole Kelvin, because we have a unit of liters here and the moles are going to cancel here, our density is always going to end up being in a unit of grams per liter because of this volume term in our R constant and because the units of molar mass are in grams per mole. So one thing to pay attention to is that if you are given a density and you're solving for molar mass and this density is in grams per milliliter or it's in kilograms per liter or anything other than grams per liter, you need to convert it to grams per liter for all of your units to cancel when you're using this equation. So let's look at an example. What is the density of natural gas, methane, CH4, at 125 degrees Celsius and 3.50 atmospheres? So what is the density? I'm solving for density. Density equals whatever. I know it's going to be in a unit of grams per liter. Let's see what other information I'm given. I'm given temperature. Temperature equals 125 degrees Celsius. I know I'm going to have to convert that to Kelvin. So I'm going to add 273, and that's going to be 398. Kelvin. I'm also given pressure. Pressure equals 3.50 atmospheres. Atmospheres is the unit that I need it in. I'm also given the identity of the gas, which is CH4. So that means I can solve for the molar mass. The molar mass of CH4 is going to be the molar mass of carbon, which if you look it up on the periodic table is about 12.1 grams per mole, plus 4 times the molar mass of hydrogen, which is about 1.001 grams per mole. And when we add all of this together, we get a molar mass of about 16.04 grams per mole. That's the molar mass of the gas. And then I also know R equals 0.0821 liter atmospheres per mole Kelvin. So this question is asking for density, so I'm going to use this version of the formula. I'm going to say density equals pressure, so 3.50 atmospheres, times the molar mass, 16.04 grams per mole, over R, 0.0821 liter atmospheres per mole Kelvin, times T, 398 Kelvin. So now let's just see what's happening here with the units. Atmospheres will cancel, Grams doesn't have anything to cancel with. Moles are going to cancel, and Kelvin are going to cancel. The unit that I have left over is a gram on the top and a liter on the bottom, which is why my unit for density is grams per liter. And when you solve this with 3 significant figures from our problem, you should get about 1.72 grams per liter. So that is how you solve for density using the molar mass and the rearranged version of the ideal gas law. You also could solve for molar mass of a gas if you were given density.